Hello students, in this lecture we are going to start with chapter 1 Electrostatics of 12th class physics NCERT textbook. What is electrostatics? Electrostatic, first of all, you should know it is also called as static electricity. It is the study of charges at rest, as statics means at rest. You have started current electricity chapter in your 10th class and current means motion. So current electricity deals with charges in motion and static electricity deals with charges at rest. So in this electrostatics, we are going to study the electric forces, electric fields and potentials which are arising due to static charges. Now let us see what is electric charge. This is a term with which you are quite familiar, but maybe you don't know the definition of electric charge. Electric charge is the basic physical property of the matter because of which it exerts or experiences electric force or electrical force. More specifically, we can say that electric charge is a basic property of the elementary particles or subatomic particles like electrons, protons. You know that generally we say that electrons have negative charge and protons have positive charge. Let us discuss an activity now or experiment which shows that there are two kinds of charges and like charges repel each other and unlike charges attract each other. But before we start with this, let me just tell you what is when a body is said to be electrified or charged. Now you have studied in your lower classes that when a plastic scale is rubbed with dry hair, it acquires the property of electrification or it acquires the property of attracting light things like light bits of paper. And when it acquires that property, we say that the scale gets charged. Now this property of attracting light bits of paper after it is rubbed with some material was first found by Thales of Miletus in Greece. He discovered that amber when rubbed with wool or silk cloth, it was attracting light objects like straw or bits of paper. Okay, and amber in Latin means electrum. It is called as electrum. So electron, electric field, electric charges or electricity, this term is derived from the Latin word electra or Greek word electron. Okay, now we know that many such pairs of materials are now known which on rubbing could attract light objects. Okay, it means indirectly they can get charged. So in this activity, we have taken glass rods, two glass rods. We have chosen silk cloth for rubbing glass rod. So this glass rod is rubbed with one silk cloth and this glass rod is rubbed with other piece of silk cloth. Okay, so this is freely hanging. When the two glass rods which are similarly rubbed with two pieces of silk cloth are brought close to each other like this, okay, then it is seen that this freely hanging glass rod gets repelled. It turns away from it. So this is the first part of the activity. In the second part, in the second diagram, we see that we have a plastic rod which is rubbed with cat's fur. Similarly, the other plastic rod is also rubbed with cat's fur and both of them then get charged. So if the charged plastic rod is brought close to this hanging charged plastic rod, again it is seen that this plastic rod gets repelled. In the third diagram, we see that a charged glass rod which is charged by rubbing with silk cloth and plastic rod which is charged by rubbing with cat's fur, when it is brought close to the hanging charged glass rod, we see that glass rod gets attracted towards plastic rod or it turns towards a plastic rod. So from this activity or from this experiment, we can conclude that first of all, we know that after rubbing they get charged. Now from the first part, we see that there is repulsion between the two similarly charged glass rods. Again in the second part, there is repulsion between two similarly charged plastic rods. In the third case, we see that charged glass rod attracts charged plastic rod. So from this activity, it was concluded that the charge on glass rod is different than the charge on plastic rod. It means there are two kinds of charges. And from this activity, it was also concluded that like charges repel each other and unlike charges attract each other, because these are like charges. Here these are also like charges, and in the third diagram we have opposite or unlike charges. Okay, I hope this experiment is clear to you. Now remember students, that when glass rod is rubbed with silk cloth, it's not only that glass rod gets charged, silk cloth also gets charged. Similarly, when plastic rod is rubbed with cat's fur, plastic rod and cat's fur both get charged. From the experiment which we have just discussed, it was proved that there are two kinds of electric charges. Now Benjamin Franklin, he was the first person who named these charges as positive and negative. By convention, the charge on glass rod or cat's fur was taken as positive, and that on plastic rod or silk is termed as negative. Okay? Now, let us see the electronic theory of frictional or static electricity. Now, why we say frictional? Because it is electricity is produced by rubbing, and we know when we rub, friction is there. Okay, so we can also call it as frictional electricity. We know that all matter, see here we know that all matter is made up of atoms or molecules. Okay, and or molecules we can say. Every matter is made up of atoms and or molecules, and normally we say they are electrically neutral. It does not mean that they do not contain the charges, but it only means that the amount of positive charges and amount of negative charges is equal, and hence they are balanced. So we say they are electrically neutral. So if we want to charge a neutral body, we need to add or remove one kind of charge. It means a charged body means an excess or deficit of charge. So how to remove or add charge to a body? How to charge a given uncharged body? Now we know that any body consists of protons and electrons are the basic charged bodies, subatomic particles which are present in any matter. Now we know that protons are positively charged and they are tightly bound in the nucleus as compared to electrons, which are negatively charged and are comparatively less tightly bound and revolve around the nucleus. Now we know that as in some solids, some of the electrons are less tightly bound in the atom compared to the other solids. So they can easily be transferred from one body to the other if we choose the proper combination of such solids. So a body can be charged positively by losing or gaining some electrons. If a body loses electrons which are less tightly bound to it, then by losing electrons it will become positively charged, and in this case if we rub and the other body gains electrons, it will become negatively charged. Okay, so a body can be charged positively or negatively by, we can say, by the transfer of electrons. So what is the cause of charging? Transfer of electrons. A body which loses electrons get positive charge, because here a body which loses electrons, in that number of electrons will be less. So total amount of negative charge will be less than the positive charge. So body which will lose electrons will get positive charge, and the body which gains electrons will have excess of negative charge, and hence it becomes negatively charged. So in the combination of glass rod and silk cloth, it is found that glass rod loses electrons and it becomes positively charged, and silk cloth gains those electrons lost by glass rod, and so it becomes negatively charged. And in this case, in the combination of plastic rod and cat's fur, it's cat's fur which loses electrons. So here it becomes positively charged, and plastic rod which gains electrons become negatively charged. Here you should remember that the number of electrons lost by one body is equal to number of electrons gained by another body. So we can say that the two bodies, their charges are equal but they are opposite. It means amount of charges is same in glass rod and silk cloth. But on glass rod it is positive charge and on silk cloth it is negative charge, but the magnitude of the charge is same, as the number of electrons lost is equal to number of electrons gained. Now let us just recall what you know already about conductors, insulators and semiconductors. We know that conductors are the substances which readily allow electricity to pass through them. We know that they have excess electric charges. It means not excess, but they have good number of free electrons, we can say. Okay, so they have electric charges which are comparatively free to move inside the material. Although they cannot on their own leave the surface of the conductor, but they are free to move inside the material, inside the conductor. Okay, so metals, human bodies, animal bodies and earth, they all are conductors, examples of conductors. Now when we talk about insulators, they offer high resistance to the passage of electricity through them. So they do not have good number of free electrons, or we can say they have no free electrons. Okay, so insulators like non-metals like glass, porcelain, nylon, plastic, they are examples of insulators. So in other words, we can say conductors allow electricity to pass through them easily. Insulators offer high resistance. They do not allow electricity to pass through them easily. Pass through electricity means pass through electrons, movement of charges. Now when we talk about semiconductors, we know that these are the substances which offer resistance to the passage of electricity, which is intermediate between conductors and insulators. So their conductivity lies between that of conductors and insulators. Okay. Now let us discuss first, instead of glass rod, if suppose somehow by choosing any other material, we rub a spoon which is held in our hand and try to get it charged. What do you think? Spoon gets charged or no? Maybe it gets charged, but the thing is, metal spoon is a conductor. So when charge is given to a conductor, a charge gets evenly distributed on its surface. As human body is also a good conductor, so through our body that charge is transferred to the earth or ground. And this process of sharing the charges with earth is called as earthing, which we'll study in the next chapters. Okay? And on the other hand, when we try to charge a glass rod which is held in our hand, by rubbing its one end with the silk cloth, it remains charged. It does not lose its charge. Why? Because when an insulator is charged in this way, then the insulator does not has free electrons. So from whichever part it is rubbed, charge stays there only. It remains static only. It does not move through the entire body of the glass rod, and hence glass rod remains charged unless we touch that charged part of the glass rod. I hope it is clear to you now why metal spoon does not get charged, because even though if it gets charged through our body, as metal is a conductor and our body is a conductor, that charge flows to the earth. We'll discuss earthing in one of the next chapters. Now let us see if there is any instrument which can detect the presence of charge on a body, which can detect if a body is charged or not. This is gold leaf electroscope. So gold leaf electroscope, you have studied in your lower classes that it detects the presence of charges on the body. Now how it is? Just have a look at the simple diagram. Okay. Now here we have a vertical metal rod. This is a metal rod housed in a box. Okay. And it has two very thin gold leaves which are attached to its bottom end. Okay. And this upper, we have a metal, we call it metal knob. Okay. Then we have a metal rod. We have two very thin gold leaves at the other end of the metal rod. Now in this case, we will consider that if suppose we touched any charged, let us say charged glass rod to the metal knob, okay, here we have a glass window so that we can have a look at the leaves. Now if we touch a glass rod which is charged with a metal knob. Now as we know, metal knob, this rod, this is a conductor, metal is a conductor. So positive charge will flow through the conductor and it will get transferred to this. It will be, if suppose we remove it, it will get evenly distributed. Or if we keep it in touch with it, the charge will get transferred here to the leaves. The leaves which are initially very close or in contact, they will move apart because as the positive charge reaches there and gets evenly distributed, so two positive charges sides of these two leaves which are now positively charges, as per the property of like charges, they will repel, and see there will be divergence between the two leaves. Okay, this is the case when it is positive charge. Even if we have negatively charged plastic rod, if we place it in contact with the metal knob, what will happen? The negative charge will flow and the two leaves will become negatively charged, and in that case also there will be divergence. Okay, so if there is no divergence, it means that the rod which we have placed here or any material which we have brought in contact with the metal knob is not charged. So the divergence of leaves tells whether the body is charged or uncharged. If no divergence, then it is not charged. If divergence is there, yes, it is charged. But how to detect whether it is positively or negatively charged? For this, first of all, we should have a known charged object with us. Let us say we have now known glass rod which is charged and positive. So then if we place in contact with the metal knob, plus we know that the two leaves are now positively charged. They have acquired the positive charge and they have shown this divergence. Now let us bring another object which we want to detect whether it is charged or not charged. And if it is charged, it is positively charged or negatively charged. So now we will remove this glass rod and bring that another unknown object whose we have to detect whether it is charged or not charged. If we bring it close in contact with metal knob, now what will happen? If there is no change in divergence, then the thing which we have brought in contact with this is uncharged. If the divergence increases, okay, the divergence between the two leaves increases, then the body is positively charged. And if the divergence decreases, then the body is negatively charged. So, if we have one known charged body, whether it is positively or negatively charged, it is known to us, then we can also detect the given body, the body whose charge is unknown, it is positively charged or negatively charged, or let us say maybe not charged. I hope you have understood the diagram construction and working of gold leaf electroscope. Now the students, in gold leaf electroscope, gold leaves get charged because the metal rod is in contact with them, and then the metal rod is in contact with the charged body externally. So that is charging by conduction, because the body whose charge we are detecting is in contact with the metal rod. Let us see now what is charging by induction. Induction here means a charged body is brought close to an uncharged body. They are not in contact, and still if we are able to charge another body, okay, this is called as charging by induction. Let us understand this through this experiment. Now we have taken two metal spheres which are identical. Sphere A, B, these are two metallic identical spheres, and they are placed on two insulating stands, and they are placed in close contact like this. So two metal spheres placed on two insulating stands, they are identical, placed in close contact like this. Initially both of them are neutral. Okay. Now a charged rod, let us say glass rod, which is positively charged, is brought close to this A metal sphere. Okay, and these two are in contact. So what will happen? Here they are in contact. So free electrons present in the two metal spheres, they will try to get accumulated on this side because they are attracted by the positive charge. But it is not that all free electrons will move towards this side. No. Because first few electrons will start moving, free electrons will start moving towards this side because of the force of attraction of this positive charge or glass rod. But as this continues, then this negative charge which is developed on the left hand side of A, okay, and when this is developed on left hand side of A, positive charge is also developed on the right hand side of B. It means the free electrons from this side has moved towards this side, and there is here less deficit or deficiency of free electrons on this side. So here negative charge is developed and here positive charge is developed. Negative charge due to the attraction and positive charge, in other words, we can say due to repulsion. But as it continues, now more free electrons will try to come this side. But what will happen? This positive charge is attracting the new incoming electrons, the free electrons this side. But this negative charge will repel now the incoming electrons. So a state of equilibrium will be reached when the force of attraction of this positive charge on those electrons will balance the force of repulsion of this negative charge on them. So when this state of equilibrium is reached, this process will stop. And now we say this side, left hand side of the sphere has developed negative charge and the right hand side of metal sphere B has developed the positive charge. Now, if we remove this glass rod from here, what will happen? If we remove this glass rod, they will again, what will happen? Again these two metal spheres will become neutral. Okay. Now if we want to charge these metal spheres, what we'll do? We'll keep this glass rod close to this only. See that they are not in contact. This glass rod is not in contact with any of the spheres. It is placed close only and now they are separated. When this is placed close to it, what will happen? And they are separated. So this positive charge will still attract these electrons, free electrons here this side. So what will happen? We can see here there will be negative charge this side and this sphere, the other sphere will get positive charge. Now what we are doing next is, now if we remove the glass rod, what will happen? If we remove the glass rod, as we see here there is no glass rod, then this will be the picture if the distance between them is still very small. Then this will redistribute this negative charge this side. It is going to attract. It will be attracted by positive charge and positive charge will be attracted by negative charge. So this will be the scene now. Now the right hand side of metal sphere A is having negative charge and the left hand side of metal sphere B is having the positive charge. Now if we increase this distance more, if we increase the distance between the two spheres which are charged, what will happen? Now this charge, negative charge which was on right hand side due to attraction of the positive charge will be uniformly distributed on the metal sphere. Okay, and this side also positively charged will be uniformly distributed on the sphere. So here we can see that we can get two equally and oppositely charged metallic spheres which we have charged without bringing a charged body in contact with them. So this method of charging is called as charging by induction. In this method, we are able to charge two metal spheres. We are able to charge them equally and oppositely. Now suppose instead of two spheres, I have only one sphere and I want to charge it. Let us say, now let us see how to give negative charge to a metal sphere. So first we have uncharged metal sphere placed on an insulating stand. So this is an insulated stand. If you want to give it a negative charge, then we have to bring a positively charged object, let us say glass rod, which is charged positively close to it. So as I have explained you now only, so here the free electrons will accumulate this side. This will become negatively charged, this side will become negatively charged, and in this case this side will become positively charged and the state of equilibrium is reached. This process will stop. First the charges will increase and then it will stop. Now if I remove the glass rod from here, what will happen? Again it will become neutral. But if I want to charge it, what I'll do? I'll keep the glass rod close to it only and touch with finger on this side, then what will happen? If the glass rod is placed close to it, then this negative charge will stay here because of attraction of the positive charge on the glass rod, and this positive charge will flow through our hand to the earth. Earthing will take place. Sharing of charges will take place of this charges positive with the ground or with the earth. And now if I remove hand and I remove the rod, the negative charge will be uniformly or equally uniformly distributed over the entire metal sphere surface. Clear? So from this activity we can see that we can charge two metal spheres equally and oppositely. We can charge a given metal sphere negatively, and we can also give a positive charge to this metal sphere by using a negatively charged plastic rod instead of a glass rod. I hope you have understood the induction, and you have understood the introduction part of this chapter. Now you know what is charge. You can explain the experiments which we have discussed today. Thank you, students.